So good morning students. Today topic is oscillators. So oscillator is an electronic circuit which produce oscillations. Okay. So these are the oscillations. So generally oscillator uses positive feedback. So we have two types of feedbacks, positive feedback and negative feedback. So negative feedback is used in amplifiers and positive feedback is used in oscillators. So here the diagram is basic amplifier and feedback network. So part of the output is given to the feedback network here, and again it is given to the amplifier. So this is the block diagram of the oscillator. So the definition for the oscillator is any circuit which is used to generate AC voltage without AC input signal. Okay, without an AC input signal is called oscillator. So simply oscillator does not have input signal. Coming to the amplifier, so here we have input signal. The amplifier has input signal and it uses negative feedback. So this is the basic difference between amplifier and the oscillator. So here to generate the AC voltage, the circuit is supplied with a energy from DC source. So here DC source and here also DC source. So here what is V0? V0 is equal to A into Vi. So V0 is equal, A is equal to V0 by Vi. So here V0 is equal to A into Vi, and here beta is equal to Vf by V0. So Vf is equal to beta into V0. So again Vf is equal to beta into Vi into A. Okay. So here there is no input signal. Vf is acts as an input signal again. So here Vf is equal to Vi. So Vi beta Vi A. So that is A beta is equal to 1. A beta is equal to 1. So these are the first condition for the oscillator. A beta is equal to 1. So here the essential conditions for maintaining the oscillator, the first point is A beta is equal to 1. That means the magnitude of the loop gain must be 1 and the total phase shift around the closed loop, the total phase shift around the closed loop is must be 0 or 360 degrees. Here the oscillator provides 180 degrees phase shift and the feedback circuit provides another 180 degrees phase shift. So these are the two conditions for maintaining the oscillations. So these two conditions are called Bark-Hansen criteria. Okay. Next. What happened when A beta is equal to greater than 1? So here A beta is equal to 1 if the phase shift is 0 or 360 degrees, but the A beta, the magnitude of the loop gain must greater than 1, then the oscillations are like this. Increasing type. Okay. So when A beta is equal to less than 1, here the oscillations are decreasing type. And third condition here, A beta is equal to 1, we are getting sustained oscillations. So this is the introduction about oscillators. Okay. So next classification of oscillators. So the first classification is according to the waveform generated. According to the waveform generated, oscillators are classified into two types: sinusoidal oscillators and relaxation oscillators. Okay, so sinusoidal oscillators generates sinusoidal voltage or current. So coming to the relaxation oscillators, it generates like square triangle. Okay, next, according to the frequency. According to the frequency generated, the oscillators are classified as audio frequency oscillators, radio frequency oscillators, VHF oscillators, very high frequency oscillators, UHF oscillators, ultra high frequency oscillators, and microwave frequency oscillators. Okay, so what is the range for audio frequency oscillators? Up to 20 kilohertz. So radio frequency 20 kilohertz to 30 megahertz. So VHF range is 30 megahertz to 300 megahertz. So ultra high frequency oscillators range is 300 megahertz to 3 gigahertz. And the microwave is above 3 gigahertz. So these are the oscillators classified according to the frequency generated. And the third one is according to the fundamental mechanism used. So this is negative resistance oscillators, and feedback oscillators. So feedback oscillators means use positive feedback in the feedback amplifiers to satisfy the Barkhausen criteria. Those oscillators are called feedback oscillators. And coming to the negative resistance oscillators, uses negative resistance of the amplifying device to neutralize the positive element of the oscillators. Okay. And the last fourth category is, the important category is according to the type of circuits, according to the type of circuits used, and these are the sine wave oscillators. So the first classification is LC tuned oscillators, and the second category is RC Phase shift oscillators. Okay, here again we have two classification, Hartley oscillator and Colpitt's oscillator. Here RC phase shift oscillator and Wien-Bridge oscillator. According to the type of circuit elements used, the oscillators are classified as LC and RC oscillators. Okay, thank you.